Lesson 4.2 and 4.3. We're going to identify inputs and outputs as relations, determine whether a relation is a function, determine domain and range, and identify independent and dependent variables. Other important keywords that you want to include here are function and relation. These are going to be new, words that we haven't talked about before. Well, we've talked about function, we haven't talked about relation. Okay? So here we go. Here we have y equals 2x plus 5. This is a function. Okay? That will always be a function. We've done those. We know how to plug them in. This is going to be our function table. Okay? So we need to plug some numbers in. Let's plug in 1. So let's do it over here. 2 times 1 plus 5. That's going to equal 7. 2 times 2 plus 5 is going to equal 9. So we're just filling in our function table here. 7, 9. If I do it again, 3 times 2 is 6, plus 5 is 11, and 4 times 2 plus 5 is going to give us, should be 13. Okay? This is our function table. Within our function table, we already have key vocabulary words. We have x and we have y. Our x column is also known as our domain. Okay? And if this is our domain, then y has to be our range. We also know that x is our independent variable and y is our dependent variable. Y depends on whatever goes into this function. So it's waiting for x to tell us what's going to go in so we can get our answer for y. What I want you to do as part of your homework is I want you to make a bridge map. Looking at the relationship between independent and dependent, range and domain, output and input. So I'll get you started. X is to y. And we can say our relating factor is x is the opposite of y as, and then you fill in the rest. You can do domain, range, dependent, independent, input, output. And if you can think of other words, use those as well. But these words are what I want to be included. And you're going to have to extend your lines to make your bridge map. Okay? So on this top row should be every name that can be used for x. And on the bottom row should be every name that can be used for y. Now, I've brought this back. This is our function. Our function has made a relation. Okay? A relation is just simply the comparison of two things. So here we have 1 and 7. These are our relations. Now, not every relation, so not every set of ordered pairs will make a function. But let's graph this one. So we go over 1 and up 7. 1, 2, 3, 4, 5, 6, 7. There's my first ordered pair. Over 2, up 9. Over 3, up 11. So that's going to be right here. And then we go over 4 and up 13. So I'm getting right there. In order to determine that this is truly a function, we know it is. It's a linear function. It made a straight line. The rule of a function is it has to pass the vertical line test. So let's get this color. Anywhere that I draw a vertical line, whoops, that's not very straight. A vertical line, it only hits 1 point. And I keep drawing my vertical lines. Every place I draw a vertical line, I only hit 1 point. So this is not only a function or a relation, it is also a function because it passed the vertical line test. So if it passes the vertical line test, it is a function. Let me erase this and show you an example of something that would not be a function. Would be a relation, but would not be a function. Let's get some circles here. Okay? Oh, what happened? There we are. So I plot some ordered pairs. Okay, I made a function table, and here's my ordered pairs. If I go to do a vertical line test, I pass there. That only hits 1 point. That only hits 1 point. But look here. This does not hit, oh my goodness. I'm sorry. Here, it hits more than 1 point. This would not be a function because it hits more than 1 point passing the vertical line test. So this example right here is not a function. Okay? Here's what I want you to do. On your notes, I want you to sketch the following ordered pairs. Just draw a quick coordinate plane and see if they would make a function. Do they pass the vertical line test? So go ahead and pause it now and do these three, and then I'll reveal the answers. This first one does not pass the vertical line test. When I do 2, two has an output of 0, and 2 also has an output of 4. To be a function, every input can only have 1 output. So on my coordinate, I would go over to 2 and I would go to 0, but then I'd also go to 2 and go up to 4. And that would not pass the vertical line test. I hit 2 dots. If you do the rest of these, you should find that yes, they do pass the vertical line test. Every function is a relation, meaning you get ordered pairs. They have a relationship, but not every relation is a function. Like we just found in our last example, this would not be a function. These two would be a function.